January 14th, 1940. Lindbergh Field, San Diego, California. The Pacific wind carries the salt of the ocean across the tarmac as Charles Emil Sorensen steps off the Douglas DC-3. His gray suit is already rumpled from the cross-country flight from Detroit, and his tie hangs loose around his collar. At 60 years old, Sorensen, vice president of production at Ford Motor Company, has seen nearly every kind of factory floor America has to offer, but he's never seen anything quite like what waits for him inside the sprawling complex of Consolidated Aircraft. The guards at the gate check his credentials twice. War is already consuming Europe, and even here, 3,000 miles from the fighting, security is tight. Sorensen adjusts his glasses and follows his escort through a maze of temporary buildings and workshops. The sound hits him first, the pneumatic hiss of rivet guns, the metallic screech of sheet metal being shaped, the shouts of foremen over the din. This isn't the ordered symphony of an assembly line. This is chaos. Inside the main production hall, Sorensen stops. His trained eye sweeps across the scene before him, cataloging everything. Men, dozens of them, swarm over the skeleton of a B-24 Liberator bomber like ants on a carcass. Some work on the wings, others on sections of the fuselage. Parts are scattered across workbenches. Components wait in disorganized piles. There's no flow here, no rhythm. Each aircraft is being built almost from scratch, piece by piece, like a custom automobile from the previous century. A Consolidated engineer appears at his elbow, eager to showcase their operation. "We can build one complete bomber every 30 days, the man says with evident pride. "Sometimes faster if we push the crews." Sorensen says nothing. His mind is already calculating. One bomber per month. Roosevelt is calling for 50,000 aircraft. At this rate, Consolidated would need decades. The mathematics are brutal and inescapable. He watches a team of 6 men wrestling a wing section into position. They're skilled craftsmen. You can see it in how they work. But they're craftsmen in an age that needs factory workers. The B-24 isn't a piece of furniture to be lovingly assembled by master artisans. It's a weapon of war, and America needs them by the thousands. "How many parts?" Sorensen asked suddenly. The engineer blinks. "I'm sorry?" "In the complete aircraft, how many individual components?" The engineer hesitates, then consults a clipboard. "Well, it depends on the variant, but roughly 500,000 parts, including 30,000 larger components." 500,000. The number hangs in the air between them. Sorensen has spent 4 decades perfecting the art of mass production. The Model T that made Henry Ford famous had 3,000 parts. The cars rolling off the Rouge River plant in 1940 have perhaps 15,000. This bomber, this beautiful, ungainly, absolutely essential machine, is 30 times more complex. But Sorensen isn't thinking about the complexity. He's thinking about the pattern. Because underneath the chaos, underneath the apparent randomness of men and materials scattered across this factory floor, he can see something else. He can see an assembly line. It comes to him not as a complete vision, but as fragments. The fuselage moving on a track, sub-assemblies feeding in from the sides, stations with a specific task, workers who don't need to be master craftsmen, just men and women trained to do one job and do it well. The wings attached here, the engines mounted there. The whole thing flowing like a river from raw materials to finished bomber, hour after hour, day after day, until every sky over every battlefield is thick with American aircraft. He just needs to build it. The only problem is, nobody believes it's possible.
February 12, 1941. The Detroit Athletic Club, downtown Detroit. The morning light cuts through the tall windows of the private dining room, casting long shadows across the white tablecloth. Charles Sorensen sits across from Edsel Ford, the only son of Henry Ford and president of the Ford Motor Company. Between them, untouched plates of eggs and toast grow cold as Sorensen spreads blueprints and hastily sketched diagrams across every available surface. Edsel Ford is 47 years old, refined where his father is rough, diplomatic where Henry is confrontational. But this morning, watching Sorensen's hands move rapidly over the drawings, explaining with barely contained excitement, Edsel sees something that makes him lean forward. He sees possibility. One aircraft every hour, Sorensen mites, tapping the blueprint with his finger. Not one per day, not one per week. Every single hour, Charlie. 24 hours a day. An assembly line 3/4 of a mile long. The numbers are staggering. Sorensen explains how the B-24 will be broken down into 5 major sub-assemblies: the nose section, the forward fuselage, the center wing section, the rear fuselage, and the tail assembly. Each section will have its own assembly area, its own team, its own flow of parts. They'll come together only at the final stage, like tributaries joining a river. The fuselage moves on a conveyor, Sorensen continues, his Danish accent thickening with enthusiasm. Workers don't move to the plane moves to the workers. Each station performs specific tasks: install hydraulic lines, mount the bomb bay doors, attach the turret mechanisms. Then it moves forward. The next station does their job, and the next, and the next. Edsel studies the sketches. His father had pioneered this exact approach with the Model T 30 years ago, revolutionizing automobile production. But an automobile has perhaps 15,000 parts. The B-24 has nearly 500,000. Consolidated won't like this, Edsel says quietly. Consolidated builds 1 bomber per month, Sorensen replies. His jaw sets in that stubborn way that everyone at Ford recognizes. Roosevelt wants 50,000 aircraft. 50,000, Edsel. The entire aviation industry combined can't deliver that number in 5 years, the way they're building now. Edsel nods slowly. He understands production in a way his father never quite did. Not just the mechanics of it, but the strategy, the long-term vision. What do you need? Sorensen meets his eyes. Everything. A new plant, new tooling, new workforce, and I need Major Fleet to agree to let us build the complete aircraft, not just components. That last part hangs in the air between them. Major Reuben Fleet, founder and president of Consolidated Aircraft, is a former Army pilot with a fierce pride in his company and his craftsmen. The idea of an automobile manufacturer mass-producing his sophisticated bomber will strike him as either naive or insulting, probably both. But Edsel Ford extends his hand across the table, and Sorensen grips it firmly. You have my support, Charlie. All of it. 3 weeks later, that support is tested. The meeting takes place in Washington, D.C., in a government office that smells of cigarette smoke and bureaucratic anxiety. George Meade, the government's director of procurement, sits at the head of the table, clearly delighted with Sorensen's proposal. To his right, Major Reuben Fleet looks like a man who's just been told his children are inadequate. Mr. Sorensen, Fleet says, his voice tight with controlled anger, Consolidated Aircraft has been building aircraft for 20 years. Our craftsmen are the finest in the world. What you're proposing, this assembly line approach, will produce inferior aircraft. Bombers aren't automobiles. They require precision, expertise, craftsmanship. Sorensen doesn't argue the point. Instead, he pulls out production figures. How many B-24s did Consolidated deliver last year? Fleet's jaw works. Production is ramping up. We're on schedule to... How many? Sorensen interrupts. The silence stretches. Everyone in the room knows the answer. Not enough. Nowhere near enough. Fleet shifts tactics. I'm prepared to offer Ford a contract. We'll need wing sections, 1,000 of them initially. Your people are skilled at forming metal. The wings would be a good fit for Ford's capabilities. 1,000 wing sections. It's a substantial contract, worth millions. Most companies would leap at the opportunity. Sorensen looks at the papers Fleet slides across the table, and then he looks back at the major. "We'll make the complete aircraft, or nothing." His voice flat and final. The words drop into the room like stones into still water. George Meade's eyes widen. One of the procurement officers actually gasps. Fleet's face goes red, then white. "That's absurd," Fleet manages. "You've never built an aircraft. You don't have a plant. You don't have trained workers. You don't have—" "We have the Model T. We have the Rouge River plant. We have 30 years in mass production. And we have something you don't have, Major Fleet. We have time. Or rather, we don't have time to waste building one aircraft per month while German forces overrun Europe." It's a calculated insult, delivered with precision. Fleet stands up, his chair scraping loudly against the floor. For a moment, it looks like he might walk out entirely. But Meade holds up a hand. "Gentlemen, please." The procurement director looks between them. "Major Fleet, I appreciate your concerns. Mr. Sorensen, I appreciate your confidence. But Ford is proposing is unprecedented. No one has ever mass-produced heavy bombers. The complexity alone—" "The complexity is exactly why it must be done this way," Sorensen says. He spreads his blueprints across the table once more. 500,000 parts, 30,000 major components. This isn't a job for artisans working at individual stations. This is a job for an industrial system, a system that can be replicated, standardized, and scaled. He points to different sections of the blueprint. Every rivet in the exact same place, every wire harness identical, every hydraulic line installed at the exact same angle in the exact same sequence. Not because we lack craftsmanship, but because consistency equals quality and quantity, both of which we desperately need. The meeting ends without resolution. Fleet leaves angry, Meade leaves uncertain. But Sorensen leaves with a letter of intent from the government. Not a contract, not yet, but permission to proceed. He takes the train back to Detroit that night, watching the dark countryside roll past his window. Somewhere out there, in a 100-acre woodlot outside Ypsilanti, Michigan, he will build something the world has never seen before. A factory that doesn't just make aircraft, it makes them inevitable, unstoppable, overwhelming. The skeptics will call it Willow Run, after the creek that meanders through the property. Sorensen calls it the future.
April 18, 1941, Willow Creek, Ypsilanti Township, Michigan. The morning fog still clings to the ground when the first bulldozer roars to life. Its diesel engine shatters the quiet of this farming community, sending flocks of starlings scattering from the willow trees that give the creek its name. The operator, a man named Tom Kelly from Dearborn, doesn't know he's making history. He only knows he has orders to clear 100 acres by week's end. Behind him, trucks are already arriving, dozens of them, then hundreds. They carry steel beams, concrete forms, lumber, rivets, electrical cable, mountains of raw material that will transform this peaceful farmland into something unprecedented. The drivers navigate muddy access roads that didn't exist 48 hours ago. They park wherever they can find solid ground. Charles Sorensen stands on a small rise overlooking the site, his coat collar turned up against the spring wind. Next to him, a younger man unfurls a massive blueprint across the hood of a Ford coupe, using rocks to hold down the corners against the gusts. This is Albert Kahn, 57 years old, arguably the most important industrial architect in America, perhaps in the world. Kahn's resume reads like a catalog of American industrial might. He designed Ford's Highland Park plant, where the first moving assembly line revolutionized manufacturing. He created the massive Rouge River complex. His firm has built hundreds of factories across the United States. In the 1930s, the Soviet government even hired him to design over 500 industrial facilities across Russia. But this project, Willow Run, will dwarf them all. 3.5 million square feet, Kahn says, tracing the blueprint with his finger. His voice carries a slight German accent, softened by decades in Detroit. In 3.5 million square feet, under one roof, the main building alone will be over 3,000 feet long, more than half a mile. The width, at the widest point, 1,279 feet. Sorensen nods, but his eyes are on the muddy field before them, already seeing what isn't there yet. How long? If everything goes perfectly, Kahn pauses, doing calculations in his head. 8 months, maybe 9. But Charlie, nothing ever goes perfectly. We don't have 9 months, Sorensen replies flatly. We have 6, maybe less. The scale of what they're attempting is almost incomprehensible. The building will be large enough to contain 70 football fields. It will house an assembly line over a mile long, not just the longest assembly line in aviation, but the longest assembly line for anything, anywhere. Workers will need bicycles just to move from one end to the other. Some will joke that you could pack a lunch before starting your walk and still need to eat it halfway there. But size alone isn't the challenge. It's the shape. You see, Henry Ford owns this land, 300 acres of farmland, straddling the border between Washtenaw County and Wayne County. For tax purposes, reasons that make sense only to accountants and lawyers, they need to keep the entire factory within Washtenaw County limits. This creates a problem. A straight line heading west would cross into Wayne County. So Kahn designs the building in an L shape, making a 90-degree turn 2/3 of the way down its length. This decision introduces new complications. You can't simply turn a B-24 Liberator 90 degrees mid-assembly. The wingspan is 110 feet. The fuselage is 66 feet long. Kahn's solution is elegant and audacious. 2 massive turntables, each capable of rotating a partially completed bomber while maintaining the rhythm of production. The aircraft will roll onto the turntable, spin 90 degrees, and continue down the assembly line without stopping. It's never been done before, one of Kahn's assistants points out nervously. None of this has been done before, Sorensen replies, and there's satisfaction in his voice rather than fear. By the end of the first week, 200 workers are on site. By the end of the second week, 800. They work in shifts, day and night, because there's no time for darkness to slow them down. 5 main contractors coordinate the chaos, each responsible for different sections. Concrete crews pour foundations, while steel workers erect framework for sections 100 yards away. Electricians string cable through portions of the building that don't have walls yet. The construction itself becomes a kind of assembly line. Kahn orders massive prefabricated sections, entire wall panels, roof sections, structural elements, manufactured off-site and trucked in for installation. It's faster this way, more efficient. The building grows in modular sections, like cells dividing. And still, production can't wait for completion. By September 1941, only 5 months after breaking ground, the first sections of the plant are finished enough to begin operations. Workers use plywood partitions to seal off completed areas from those still under construction. In one section, riveters are installing hydraulic systems on bomber components. 50 feet away, construction crews are still pouring concrete floors. The noise is constant, deafening. The pneumatic hammer of rivet guns, the screech of metal being cut and shaped. the shouts of foremen trying to coordinate 1,000 tasks simultaneously. And under it all, the low rumble of the B-24 components beginning their slow, methodical journey down an assembly line that grows longer every single day. Sorensen walks the construction site daily, sometimes twice daily. He knows every supervisor by name. He stops to watch welders at work, studies the rhythm of the concrete crews, observes how materials flow from delivery trucks to installation points. He's looking for bottlenecks before they become catastrophes, inefficiencies before they calcify into habits. One afternoon in late September, standing near the center of the main assembly floor, now mostly roofed but still missing sections of walls, Sorensen turns slowly in a complete circle. Around him, the factory breathes with nascent life. The skeleton is becoming flesh. The dream is becoming steel and concrete. A young engineer approaches, clipboard in hand. "Mr. Sorensen, the government inspectors are here. They're asking when we'll deliver the first complete B-24. Sorensen doesn't answer immediately. He's looking up at the ceiling, at the massive overhead cranes being installed, at miles of conveyor tracks being laid. Then he looks back at the engineer. "Soon. Tell them soon." What he doesn't say, what he barely allows himself to think, is that soon needs to be very soon indeed. Because on the other side of the world, German forces are pushing deeper into Soviet territory. In the Atlantic, merchant ships are being sunk faster than they can be built. And in the Pacific, tensions with Japan are approaching a breaking point. The world is running out of time. And Willow Run is America's answer. Still unfinished, still unproven, but growing stronger with every passing day.
June 22, 1942, Elm Street, Detroit, Michigan. Margaret Sullivan stands in her backyard, holding a pair of aluminum cooking pots that her mother gave her as a wedding gift 8 years ago. The morning sun glints off their polished surfaces. They're good pots, well made, hardly used. In the kitchen she has newer ones, stainless steel, that work just as well. Down the street, a flatbed truck idles at the curb. Neighbors are already gathering, carrying aluminum lawn chairs, old radiators, copper wire, steel tools they no longer need. A hand-painted banner stretched across the truck bed reads, "Aluminum for Defense." Margaret's 8-year-old son, Tommy, appears at her elbow. "Mom, are you sure?" She looks down at him, then back at the pots. "They're making bombers, Tommy. Real bombers. Your father's working on them right now at Willow Run." She walks to the truck and places the pots carefully in a growing pile of donated aluminum. These pots might become part of a B-24, might help end this war faster. All across America, similar scenes unfold. In Portland, Oregon, a Boy Scout troop collects nearly 2 tons of scrap rubber in a single weekend. In Birmingham, Alabama, housewives donate old cooking pans, cigarette foil, even their makeup compacts, anything containing aluminum. In rural Kansas, farmers strip old equipment for parts, separating steel from copper from brass with practiced efficiency. The numbers are staggering. Between Pearl Harbor and the end of 1942, Americans will collect over 400,000 tons of scrap metal. Old cars become fuselage panels. Discarded radiators become engine components. Aluminum lawn furniture transforms into wing sections. The entire nation has become a supply chain. But raw materials are only part of the equation. At Willow Run, Charles Sorensen faces a different crisis: people. The plant needs 42,000 workers at full capacity, not craftsmen. Those are too rare, too expensive, and too long to train. Sorensen needs ordinary people who can be taught specific tasks and taught quickly. The problem is that most able-bodied men are being drafted. Every month, 8,200 workers leave Willow Run for military service. They must be replaced,
retrained, and brought up to speed before the assembly line grinds to a halt. Sorensen's solution is radical. Hire women. Not as secretaries or nurses, those traditional roles that society deems appropriate, as riveters, welders, hydraulic technicians, sheet metal workers, the jobs that built America's automobiles and now will build America's Air Force. The recruitment posters go up in July 1942. They show women in work clothes, sleeves rolled up, safety goggles in place. "We can do it," one declares, featuring a woman flexing her arm, a red bandana tied around her hair. The image will become iconic, but right now, it's just recruitment. They come in thousands. Farm wives from rural Michigan, young women from Detroit's neighborhoods, housewives whose husbands are already overseas, African American women from the South seeking opportunity in northern factories that had previously excluded them. They arrive by bus, by train, by hitchhiking rides from friends. Rose Will Monroe is 23 years old when she walks through Willow Run's gates in August 1942. She's from Kentucky, a widow with 2 young daughters. She's never worked in a factory before, never used a rivet gun, never thought she would. They assigned her to Station 47, Fuselage Assembly. An older foreman, a man named Carl Jenkins, who's too old for the draft, shows her how to load the rivet gun, how to position it, how to squeeze the trigger with just the right pressure. Too little, and the rivet won't seat properly. Too much, and you damage the aluminum skin. Every rivet matters, Jenkins tells her, his voice nearly drowned by the factory noise. A bad rivet 30,000 feet over Germany? That's not just a mistake. That's somebody's life. Rose practices on scrap metal for 2 hours. Then Jenkins puts her on the line, working next to experienced riveters who've been here since September 1941. The fuselage section moves past at a steady pace. She has 90 seconds to install 6 perfect rivets. Then the section moves on and another appears. The first day, her shoulders ache. The second day, her hands cramp. By the end of the first week, she can barely lift her arms. But by the end of the second week, something changes. Her body adapts. The movements become automatic. 6 rivets in 80 seconds, then 75, then 70. Across the factory floor, similar transformations occur. Mildred Jackson, who worked as a domestic servant in Alabama, becomes an expert at installing hydraulic lines. Betty Reed operates a crane, moving multi-ton components with millimeter precision. Ida Barnes works the night shift in wind assembly. Her husband works the day shift building engines at the Packard plant 15 miles away. They see each other only on Sundays. And the men who remain, those too old for military service or with essential skills that keep them stateside, work alongside the women without the prejudice that defined previous decades. There's no time for prejudice when you're trying to build a bomber every hour. The assembly line doesn't care about gender or race. It only cares about precision, speed, and consistency. But housing becomes a nightmare. Ypsilanti, a quiet college town of 12,000 people, suddenly faces an influx of 40,000 workers. There aren't enough apartments, not enough houses, not enough rooms. Workers sleep in shifts in the same beds. One person works days while another sleeps. Then they switch. The government scrambles to build temporary housing. Rows of identical units spring up near the factory, small, cramped, but better than sleeping in cars or makeshift tents. Some workers commute from Detroit and hour each way on overcrowded buses. Others sleep in the factory itself during breaks, too exhausted to go home. And still, the materials flow in. By train, by truck, by barge on the Detroit River. Aluminum sheets from Alcoa plants in Pennsylvania, steel tubing from Pittsburgh, plexiglass from Ohio, rubber from tire factories converted to aircraft production. Every day, hundreds of tons of raw material enter one end of Willow Run. At the other end, not yet, but soon, complete B-24 Liberators will emerge. The transformation is happening. From scrap pots in Detroit backyards to wing sections at Willow Run. From housewives in Kentucky to skilled riveters on the assembly line. From an impossible dream sketched on Charles Sorensen's blueprints to a growing reality 3/4 of a mile long. America is learning to build aircraft the way it once learned to build automobiles. Not one at a time, but by the thousands. Not through craftsmanship alone, but through system, through process, and through the determined effort of ordinary people doing extraordinary work. The arsenal is taking shape.
December 10th, 1942, Willow Run Assembly Floor, 4:47 a.m. The factory never sleeps, but this particular morning holds something different, a tension that ripples through the workers like static electricity. At the end of the mile-long assembly line, where the final stations complete their work and massive doors open to the adjoining airfield, a B-24 Liberator sits complete. Not a component, not a subassembly shipped to California for Consolidated to finish. A complete bomber built entirely at Willow Run from beginning to end. Charles Sorensen walks around the aircraft slowly, his practiced eye checking every rivet line, every panel seam, every access door. He's 61 years old now, and the past 2 years have added a decade to his appearance. The critics have been merciless. Newspapers mock Willow Run as Will It Run. Congressional investigators question whether Ford has wasted millions on an impossible project. Behind him, a small crowd gathers. Ford executives, government inspectors, representatives from the Army Air Forces, and workers, dozens of them still in their coveralls, still smelling of machine oil and aluminum shavings, watching the man who promised them they could build aircraft like automobiles. The test pilot climbs into the cockpit. Captain James Warner, Army Air Forces, a veteran of 30 combat missions over North Africa. If this bomber has problems, if Sorensen's revolutionary assembly line has produced anything less than airworthy, Warner will find out, possibly the hard way. The 4 Pratt & Whitney engines cough, then roar to life. The propellers spin into silver blurs. The B-24 begins rolling toward the runway, and every person on that factory floor holds their breath. 20 minutes later, Warner brings the bomber back, landing smoothly on Willow Run's longest runway. He climbs down, walks directly to Sorensen, and extends his hand. "She flies," Warner says simply. "Flies as well as any B-24 I've ever flown." The factory erupts in cheers. But one successful aircraft doesn't solve the fundamental problem. Willow Run isn't producing anywhere near the promised rate. The plan called for 5 B-24s per day by now, 150 per month. The reality? In all of December 1942, Willow Run will deliver exactly 1 complete bomber. The bottlenecks are everywhere. Consolidated keeps changing the design, adding new gun positions, modifying the bomb bay, upgrading electrical systems. Each change ripples backward through the entire assembly process. Workers trained to install one type of turret suddenly face a completely different model. Parts ordered months ago no longer fit. Worse, Consolidated's original blueprints are inadequate for mass production. They're craftsman drawings, showing what the finished component should look like, but not specifying the exact tolerances needed for interchangeable parts. Ford engineers must reverse engineer thousands of components, creating new technical drawings from scratch. Some days, engineers produce more than a mile of new blueprints. And then there's the learning curve. Rose Will Monroe might be able to install 6 rivets in 70 seconds now, but what happens when the design changes and those 6 rivets become 8 rivets in different positions? Training begins again. Efficiency drops. The assembly line stutters. January 1943 brings more problems. The Army Air Forces demands modifications for cold weather operations.
Soviet forces need bombers that can function at 40 degrees below zero. That means different hydraulic fluid, different lubricants, different electrical heating for guns and bomb bays. More changes, more delays. Edsel Ford collapses at his desk in February 1943. Stress, the doctors say. The ulcers that had plagued him for years have worsened. They send him home to rest, but everyone knows the B-24 project is eating him alive. His father, Henry Ford, now 80 years old and increasingly erratic, interferes constantly, countermanding Edsel's decisions, creating confusion in the chain of command. By March 1943, Willow Run has produced only 14 complete B-24s. The critics sharpen their knives. Senator Harry Truman, heading a committee investigating war production, tours the plant and emerges unimpressed. The Ford plant is a disgrace. All that investment and almost no production, he tells reporters. The pressure on Sorensen becomes crushing. Build faster. Build more. The war is turning against the Allies in too many places. American bombers are needed over Germany, over Italy, over occupied France. Every day of delay means more German forces entrenched, more civilians under regime control, more time for the enemy to prepare defenses. Sorensen responds the only way he knows, by returning to first principles. He brings in efficiency experts who watch every station, timing every movement, identifying every wasted second. He reorganizes the part supply system, implementing a revolutionary just-in-time approach where components arrive at each station exactly when needed, not hours early, not minutes late. He establishes massive training programs. The Aircraft Apprentice School brings in 8,000 students per week, teaching them specific skills in intensive courses. Not general aviation knowledge, they don't have time for that. Specific tasks. How to install this wire harness, how to mount that gun turret, how to test this hydraulic system. Each worker becomes an expert at one thing. Most importantly, Sorensen wins a critical battle: control. Congressional investigators determined that Consolidated's constant interference is crippling production. In April 1943, complete authority for Willow Run passes to a single plant manager reporting directly to Sorensen. No more design changes without approval. No more conflicting orders. The assembly line finally has the stability it needs. But April 1943 also brings tragedy. Edsel Ford dies on May 26, 1943. Cancer, officially. But everyone at Willow Run knows the truth. The stress killed him. The impossible demands, the constant criticism, the burden of trying to achieve what no one had ever achieved before, mass-producing the most complex aircraft in the world. Charles Sorensen attends the funeral on a gray Tuesday morning. He stands at the graveside with hundreds of Ford employees, watching as they lower Edsel Ford into the ground. The man who believed in him, the man who supported his vision when everyone else called it impossible. That night, Sorensen returns to Willow Run. He walks the entire length of the assembly line, from raw materials to final assembly. He watches the night shift workers at their stations, installing, testing, checking, moving the bombers forward inch by inch. "We're going to make this work," he tells a supervisor. "For Edsel, we're going to make it work."
August 1943. Willow Run assembly floor, Station 127. Something has changed. You can feel it in the rhythm of the work, in the confidence of the workers, in the steady flow of bombers moving down the line. The stuttering, uncertain pace of early 1943 has given way to something smoother, more assured. At Station 127, Roswell Monroe installs rivets with mechanical precision. 8 rivets in 62 seconds. The fuselage section moves on. Another appears. 8 more rivets. It's meditation through repetition, and she's not alone. Every worker on this floor has found their rhythm, their groove, their perfect synchronization with the assembly line's relentless pace.
The numbers tell the story. January 1943, 14 aircraft. February, 17. March, 21. The growth is slow but steady. April brings a surge, 32 bombers. May, 53. June, 75. By July, Willow Run produces 105 B-24 Liberators, more in 1 month than in the entire previous year. Charles Sorensen's innovations are finally paying dividends. The just-in-time parts delivery system means workers no longer waste time searching for components. They arrive exactly when needed, positioned exactly where required. A worker at Station 94 reaches for a hydraulic actuator, and it's there. Not in a warehouse 100 yards away, but right there, at arm's length. The training programs have created a workforce of specialists. New workers complete intensive 3-week courses before ever touching a bomber. They practice on mock-ups, on training fixtures, until muscle memory takes over. By the time they reach the floor, they're not learning, they're executing. Most critically, design stability has transformed chaos into consistency. With Consolidated's interference eliminated, modifications happen in controlled batches. When the Army Air Forces requests changes, they're implemented between production runs, not midstream. Workers learn one configuration thoroughly before adapting to the next. September 1943 becomes a turning point. The plant produces 148 bombers. October, 197. The critics have gone quiet. Senator Truman, who called Willow Run a disgrace 6 months earlier, now praises it as a model of American industrial capacity. But it's not just quantity, it's quality. Army Air Force's inspection reports show that Willow Run B-24s have fewer defects than those built at Consolidated's San Diego plant or Douglas Aircraft's Tulsa facility. The craftsmen in California might be more skilled individually, but Sorensen's system produces more consistency. Every rivet in the exact same position, every wire harness routed identically, every hydraulic line installed at precisely the same angle. This standardization has unexpected benefits. When a B-24 needs repairs in the field, whether on an air base in England or a dirt strip in New Guinea, mechanics find everything exactly where the manuals say it should be. A bomb bay door from a Willow Run bomber is perfectly interchangeable with one from any other Willow Run bomber. It's the Model T principle scaled up to bombers. By November 1943, the factory achieves something remarkable: 24-hour continuous production. There are no more shutdowns for shift changes, no gaps in the workflow. As the day shift clocks out, the night shift seamlessly continues the work. The assembly line never stops moving. Bombers flow from Station 1 to Station 315 in an unbroken stream. Workers develop pride in their specific stations. The hydraulics team at Stations 88 to 92 boast that they can complete their installations faster than any other section. The electrical crew at Stations 140 to 147 claims 0 defects for an entire month. Competition emerges, not hostile, but spirited, each team pushing to be the best at their specialized task. December 1943, 248 bombers, more than double the output from just 6 months earlier. The impossible goal, 1 bomber per hour, no longer seems impossible. It seems inevitable. In the break room, workers gather around a map of Europe pinned to the wall. Red pins mark cities where American forces are stationed. Blue pins show recent bombing missions. Someone has started adding green pins for every 100 bombers Willow Run produces. The map is getting crowded with green pins. Rose Will-Monroe stands before that map during her lunch break, studying it. Her brother is a navigator on a B-17 Flying Fortress stationed in England. Somewhere over there, B-24s built right here at Willow Run are flying missions, dropping bombs on targets, fighting their way through enemy territory. She touches one of the green pins. 8 rivets, she murmurs to herself. 8 perfect rivets. Because that's what it comes down to, really. Not grand strategy or political will or even Sorensen's brilliant engineering. It comes down to 8 rivets installed correctly, 62 seconds at a time, by a widow from Kentucky who never imagined she'd be building bombers. Multiply that by 42,000 workers. Multiply it by 3 shifts a day. Multiply it by every rivet, every bolt, every wire, every hydraulic line in a 500,000-part aircraft. That's how you turn the tide. That's how you overwhelm an enemy. Not with individual acts of heroism, but with systematic, relentless, unstoppable production.
April 1944. Willow Run, Final Assembly Station. The clock on the factory wall reads 3:14 p.m. A B-24 Liberator rolls off the assembly line, its bare aluminum skin gleaming under the overhead lights. Workers step back as the tow tractor hooks up, preparing to pull the bomber toward the paint station. 3 minutes later, 3:17 p.m., another bomber emerges. And at 4:12 p.m., another. Charles Sorensen stands at the observation platform, stopwatch in hand, documenting what everyone already knows. Willow Run has achieved its goal: 1 bomber every 63 minutes, some hours even faster. The impossible promise made 4 years ago in San Diego has become mundane reality. April 1944 will be remembered as the month everything came together. In just 4 weeks, working 2 9-hour shifts, 6 days a week, Willow Run workers produced 453 complete B-24 Liberators. That's 1 finished bomber every 63 minutes, sustained across an entire month. The factory operates like a living organism now. Parts flow from nearly 1,000 suppliers across America. Packard builds the engines in Detroit. Smaller firms produce everything from landing gear to gun turrets. Even refrigerator factories contribute fuselage panels. These components arrive at Willow Run on precisely timed schedules, moving from receiving docks directly to assembly stations. The L-shaped assembly line has become a marvel of industrial choreography. At the 90-degree turn, massive turntables rotate half-completed bombers while work continues without pause. Workers have learned to install components while the aircraft spins slowly beneath them, a skill that would have seemed impossible 2 years ago. But peak production brings new challenges. The sheer volume of bombers exceeds the Army Air Force's ability to process them. Completed B-24s queue up on Willow Run's airfield, dozens of them, waiting for ferry pilots to fly them to modification centers or directly to combat units overseas. On May 15, 1944, workers gather for a special ceremony. The 5,000th B-24 Liberator built at Willow Run rolls off the assembly line. Photographers capture the moment, rows of workers, mostly women, surrounding the bomber, their faces showing pride and exhaustion in equal measure. Rose Will-Monroe is selected to pose for additional publicity photographs. She stands on a ladder, rivet gun in hand, demonstrating her work for the cameras. The image will circulate in newspapers, recruitment posters, even government war bond promotions. She becomes the face of Rosie the Riveter, though thousands of other Roses work beside her, equally skilled, equally essential. June 1944, 428 bombers. It's the peak, the single highest production month in Willow Run's history. The factory floor hums with confident efficiency. Every station knows its job. Every worker executes without wasted motion. The assembly line flows like water. Then comes the news everyone has been waiting for. June 6, 1944, D-Day. Allied forces stormed the beaches of Normandy. Above them, providing air support, are hundreds of American bombers. Many of them, perhaps most of them, rolled off assembly lines at Willow Run.
The factory celebrates quietly. There's no time for parties, no pause in production. But workers understand what they've accomplished. Every bomber they build is up there, over France, helping American soldiers fight their way inland. The rivets Rose Monroe installs this afternoon might be in an aircraft bombing regime positions tomorrow. September 1944 brings another milestone, the 6,000th bomber. Production has become so routine that the ceremony is brief. A plaque is unveiled, photographs are taken, and everyone returns to work. There are still bombers to build. Ford now plans to increase production even further, 650 bombers per month, one every 45 minutes. New efficiency improvements are implemented, additional training programs refined. The system that took years to develop continues to evolve, to improve, to optimize. But by late 1944, the strategic situation changes. Allied forces are pushing deeper into Germany from the west, while Soviet forces advance from the east. The regime's industrial capacity, the factories, the refineries, the transportation networks, is being systematically destroyed. The need for more bombers, while still present, becomes less urgent. In December 1944, the Army Air Forces begins reducing orders, not canceling, the war is far from over, but scaling back. Willow Run's production target drops to 400 bombers per month. Some workers are reassigned to other projects. The night shift shrinks. January 1945, 376 bombers. February, 342. The numbers decline not because of failure, but because of success. The Allied air forces have achieved overwhelming superiority. The skies over Europe are dominated by American and British aircraft. Regime forces can barely launch defensive missions. Charles Sorensen, now 64 years old, watches the assembly line with mixed emotions. They've accomplished everything they promised and more. Nearly 9,000 B-24 Liberators built at Willow Run, almost half of all Liberators produced during the entire war. On May 7, 1945, Germany surrenders. In Europe, the war is over. At Willow Run, the assembly line continues running. Japan still fights on, and B-24s are needed in the Pacific theater. But everyone knows the end is approaching. The impossible factory, built to produce impossible numbers of impossibly complex aircraft, has succeeded beyond anyone's expectations.
June 28, 1945. Willow Run, 2:37 p.m. The factory floor is quieter than it's been in 4 years. Not silent, it's never silent when the assembly line runs, but noticeably subdued. Workers move through their stations with practiced efficiency, but there's something different in the air. A sense of ending. The B-24 Liberator moving down the line this afternoon will be the last. Serial number 44-53686. The final bomber from a factory that has produced 8,685 aircraft since December 1942. Rose Monroe installs her rivets for the last time on a B-24. 8 perfect rivets, placed with the same precision she's maintained for 3 years. But her hands shake slightly as she sets down the rivet gun. She's not alone. All around her, workers pause momentarily, realizing they're completing something historic. At Station 315, Final Assembly, supervisors attach a small plaque to the nose of the last bomber. It lists production statistics: 8,685 complete aircraft, thousands more knockdown kits shipped to Douglas and Consolidated for assembly elsewhere, millions of components, billions of rivets, all built by civilian workers, many of whom had never seen an aircraft before 1941. Charles Sorensen is not present for the ceremony.
He left Ford Motor Company in 1944, pushed out by internal politics and family feuds that plagued the company after Edsall's death. But his legacy fills this factory floor. Every efficient station placement, every optimized workflow, every system that transformed impossible into routine. The last B-24 rolls toward the exit doors. Test pilots will fly it tomorrow, putting it through the same rigorous evaluation every Willow Run bomber receives. Then it will join the fleet, bound for the Pacific, where American forces are still fighting Japanese positions across island chains. But even as this bomber completes assembly, the American war is effectively over. Japan is isolated, its navy destroyed, its industry bombed into rubble. On August 6, 1945, just 6 weeks after the last Willow Run bomber, an atomic bomb will fall on Hiroshima. 3 days later, another on Nagasaki. On August 15th, Japan will surrender, and World War II will end. The workers at Willow Run don't know this yet. They know only that their job is finished. The assembly line shuts down. The station tools are cleaned and stored. The overhead cranes go still. For the first time since 1941, Willow Run is silent. What happens next is the predictable aftermath of any war industry. The government no longer needs bombers. Ford no longer needs 42,000 aircraft workers. The women who became riveters, welders, hydraulic technicians, they're told to return home, to make room for returning soldiers, to resume domestic roles that suddenly feel confining after 3 years of skilled industrial work. Rose Will-Monroe tries. She goes back to Kentucky, to her daughters, to the quiet life she left in 1942. But something has changed in her. She knows what she's capable of now. She's built aircraft that flew across oceans and fought in history's largest war. 8 rivets at a time, she helped defeat tyranny. Within 6 months, she's back in Michigan, working for a construction company. She'll spend the rest of her life in skilled trades, never returning to the traditional roles society expected of women. She's not alone. Thousands of Willow Run women discover similar truths about themselves. The factory itself faces an uncertain future. Ford doesn't want it. The company never planned to continue aircraft production after the war. The building is too large, too specialized for automobile manufacturing. For a while, it sits empty, a monument to what American industry accomplished when necessity demanded the impossible. Eventually, Kaiser Frazer Automobile Company will buy the facility, attempting to produce cars there. But the factory built for bombers never quite adapts to peacetime production. Later, it will house various manufacturing operations, none capturing the intensity and purpose of those war years. By the 21st century, most of Willow Run will be demolished. A small section remains, preserved as a museum, a reminder of what Americans achieved when their nation needed them. But the real legacy isn't the building, it's the transformation. Willow Run proved that the most complex machines could be mass-produced with the right systems, the right training, the right commitment. The techniques developed there, just-in-time parts delivery, standardized processes, intensive specialized training, would influence manufacturing for decades. Toyota's famous production system draws directly from lessons learned at Willow Run. More importantly, Willow Run proved what American civilians could accomplish. Not soldiers, not military professionals, but ordinary people transformed into extraordinary workers. Housewives who became riveters, farmers who mastered precision hydraulics,
Teenagers who learned to operate cranes moving tons of delicate aircraft components. They took scrap metal from backyard donation drives and aluminum sheets from Pennsylvania mills and turned them into 8,685 four-engine bombers. They built aircraft that flew over North Africa and Italy, over France and Germany, over island chains whose names most Americans couldn't pronounce. And they did it not through individual heroism, but through systematic collaboration. Each worker contributing their small part, 8 rivets, 1 hydraulic line, a single electrical connection, that combined into machines capable of changing the war's outcome. The Axis regime's industrial capacity never matched this. German aircraft production, despite their engineering prowess and their early advantages, couldn't compete with the sheer overwhelming scale of American mass production. They built excellent aircraft in limited numbers. America built good aircraft in impossible numbers. That difference decided the war in the air. And Willow Run, that impossible factory built in a Michigan woodlot, exemplified the difference.
Let's step back from the individual stories and consider the mathematics of what happened. Because numbers, in the end, tell a story that individual heroism cannot fully capture. In 1939, when war broke out in Europe, the entire American aviation industry produced fewer than 6,000 aircraft of all types. The nation had perhaps a dozen aircraft manufacturers, employing maybe 50,000 workers total. The idea of producing tens of thousands of bombers seemed as fantastical as reaching the moon. By 1944, that same industry produced over 96,000 aircraft in a single year. Fighter planes, bombers, transport aircraft, trainers. American factories delivered 1 aircraft every 5 minutes, every single day, for 12 months straight. Willow Run's contribution, 8,685 B-24 Liberators, plus thousands of knockdown kits assembled elsewhere. That represents approximately 40% of all B-24 production during the entire war. One factory, built in farmland, operated largely by workers with no previous aircraft experience, produced nearly half of America's most produced heavy bomber. But Willow Run was just one facility. Across America, similar transformations occurred. Consolidated Aircraft's San Diego plant ramped up production. Douglas Aircraft opened a massive facility in Tulsa, Oklahoma. North American Aviation built P-51 Mustang fighters in Inglewood, California. Boeing produced B-17 Flying Fortresses in Seattle and B-29 Superfortresses in Wichita, Kansas. Every factory faced similar challenges: inexperienced workers, material shortages, design modifications, quality control under extreme time pressure. Every factory found solutions through innovation, adaptation, and determination. The regime's aircraft production, by comparison, peaked at about 40,000 aircraft in 1944, less than half the American output. And those numbers obscure qualitative differences. Regime factories struggled with material shortages as Allied bombing destroyed supply chains. Their workforce included forced laborers and prisoners who had no incentive for quality work and every incentive for subtle sabotage. American aircraft rolled off assembly lines with consistent quality. Regime aircraft became increasingly unreliable as shortcuts and substitutions became necessary. The disparity extended beyond numbers to logistics. American factories didn't just build aircraft, they built complete aircraft ready for combat operations. Engines, instruments, radios, guns, everything installed and tested. Regime production often delivered airframes without engines, or engines without instruments, forcing final assembly at field locations under combat conditions. And replacement parts. American factories produced not just aircraft, but comprehensive logistics support. When a bomber needed a new engine or a fighter required a replacement propeller, the parts existed in abundance, properly cataloged, readily available. This is the revolution Charles Sorensen understood in 1940, standing on that consolidated aircraft factory. Not just mass production of aircraft, but mass production of everything aircraft needed: parts, tools, training manuals, maintenance equipment. Willow Run alone required parts from nearly 1,000 suppliers across America. Packard built the Pratt & Whitney engines under license in Detroit. Smaller firms produced specialized components: hydraulic actuators, electrical generators, gun turrets, bomb racks. Even furniture manufacturers contributed, using their woodworking expertise to build interior components. This supply chain represented tens of thousands of American companies, employing millions of workers, all coordinated through what would later be recognized as one of history's great logistical achievements: just-in-time delivery before the concept had a name, quality control standards before ISO certification, supply chain integration before business schools taught the principle. The home front mobilization extended beyond factories. Scrap drives collected 400,000 tons of material. Victory gardens freed agricultural capacity from military needs. Rationing of rubber, metal, and gasoline reduced civilian consumption, redirecting resources to war production. This wasn't government tyranny forcing compliance. This was voluntary sacrifice on massive scale. Children collected scrap metal. Housewives donated aluminum cookware. Farmers contributed old equipment. Everyone participated because everyone understood what was at stake. And the financial cost. Willow Run alone cost $47 million to construct, approximately $850 million in 2025 dollars. That's for one factory. Multiply that across hundreds of facilities, and the investment reaches staggering levels. The government financed much of it through war bonds, essentially borrowing from citizens to build the infrastructure to save civilization. Those citizens bought $185 billion in war bonds during World War II, roughly $3.3 trillion in modern terms. They were literally investing their savings in victory. The return on that investment? By late 1944, Allied air forces achieved complete air superiority over Europe. Regime fighters rarely challenged bombing missions. Their industrial capacity was systematically destroyed. Their transportation networks collapsed under constant aerial attack. Their ability to wage war deteriorated with each passing month. In the Pacific, American aircraft carriers deployed hundreds of fighters and bombers, overwhelming Japanese defenses. Island after island fell to forces supported by overwhelming air power. Even the atomic bombs that ended the war were delivered by B-29 bombers, products of the same mass production system that created Willow Run. The numbers tell a story of transformation, from 6,000 aircraft per year to 96,000, from 50,000 aviation workers to millions, from primitive craft production to sophisticated mass manufacturing, all accomplished in roughly 4 years. Charles Sorensen's promise, one bomber every hour, seemed impossible in 1940. By 1944, it was merely another day at the factory. That's the power of systematic thinking applied to seemingly impossible problems. That's what American industry achieved when challenged by existential threat.
December 2024, Ypsilanti, Michigan, the Yankee Air Museum. A restored B-24 Liberator sits in climate-controlled preservation, its aluminum skin polished to mirror brightness. Visitors walk around it slowly, cameras clicking, voices hushed with something approaching reverence. Most don't know the stories. They see a big aircraft, impressive in its size and complexity. They read the plaques about specifications and combat history. But they don't see the 8 rivets installed by Roswell Monroe. They don't see the hydraulic lines connected by Mildred Jackson. They don't see the thousands of individual contributions that transformed aluminum sheets and steel tubing into this machine. One small section of the original Willow Run factory remains, preserved as part of the museum. It's perhaps 5% of the original building. Everything else was demolished decades ago. Visitors can stand on the actual factory floor where the assembly line once ran, can see photographs of workers at their stations, can read testimonials from the men and women who built bombers for $1.20 per hour. But preserving history isn't the same as understanding it. To truly understand what happened at Willow Run, you must grasp not just what was built, but what was transformed. The women who became skilled industrial workers discovered capabilities society had told them they didn't possess. The vast majority never returned to purely domestic roles. They'd proven themselves in the most demanding environment imaginable. That knowledge changed them permanently, changed their daughters, changed the next generation of American women. The engineers who developed just-in-time logistics and quality control systems created methodologies that would reshape global manufacturing. Japanese industrialists studied American wartime production techniques and adapted them into the Toyota production system, the same lean manufacturing principles now taught in business schools worldwide. The principle that complexity doesn't prevent mass production, that even aircraft with 500,000 parts can be built on assembly lines, revolutionized aerospace engineering. Every commercial jetliner since 1945 has been built using variations of techniques pioneered at Willow Run. And the basic insight that Charles Sorensen brought to consolidated aircraft in 1940, that systematic processes executed by trained but not necessarily expert workers can outproduce small numbers of master craftsmen, this principle extends far beyond manufacturing. It's fundamentally about leverage, about how intelligent system design multiplies human capability. The regime lost World War II for many reasons: strategic blunders, overextension across multiple fronts, underestimating enemies. But among the most fundamental reasons, they never understood this principle of systematic mass production. They had excellent engineers designing sophisticated weapons, but they never built the systems to produce those weapons in overwhelming numbers. American industry, led by facilities like Willow Run, didn't just build more aircraft. They built the infrastructure, the training systems, the supply chains, the quality processes, everything needed to sustain production at previously impossible scales. That's the real legacy. Not the 8,685 bombers, not even the strategic impact of those bombers on the war's outcome. The real legacy is the proof that systematic thinking, applied rigorously to complex problems, can achieve what appears impossible. Today, that same principle applies everywhere. The smartphones in our pockets contain components more complex than anything in a B-24, yet they're mass-produced by the billions. The computers that guide modern aircraft have processing power that would have seemed magical in 1944, yet they're reliable, standardized, and interchangeable. All of it traces back in some way to lessons learned during World War II about how to build complex things at scale. Willow Run was a laboratory for those lessons, a proving ground for principles that now underpin global manufacturing.
Charles Sorensen died in 1968 at age 77, largely forgotten by the public. He never received the acclaim given to military leaders or political figures, but his contribution to winning World War II, his insight that aircraft could be mass-produced like automobiles if you designed the right systems, changed warfare and changed the world. Roswell Monroe died in 1997 at age 77. She spent her later years telling her story to school groups, always emphasizing that she wasn't special. She would say, "I just did my job. We all just did our jobs." But that collective effort, 42,000 people just doing their jobs, each contributing their small part, that's what defeated tyranny. The last surviving Willow Run workers are now in their late 90s or 100 years old. Soon, there will be no one left who remembers what it felt like to work in that massive factory, to watch bombers roll off the assembly line hour after hour, to know that your work directly contributed to the most important struggle of the 20th century. But the principles they proved remain. The systems they developed persist. The transformation they achieved, from impossible to routine through systematic process improvement, that legacy will endure as long as humans build complex things. Standing in that museum, looking at the restored B-24, you can almost hear the echo of rivet guns, almost see the ghost of the assembly line extending into the distance, almost feel the determination of people who believed they could do the impossible, and then did it. 8 rivets at a time, 1 bomber every hour, until the war was won.